Today what we're going to be doing is adding and subtracting, multiplying, and dividing complex numbers. Now, last year in Algebra 2 Trig, we did work with complex numbers, so it's going to be kind of the same process. So what we're going to do is kind of review what we talked about last year, where when we add or subtract, we want to combine our like terms, meaning we can't combine our real parts and our imaginary parts, or I. They have to stay separate. So right here we have 3 plus 7i minus 6 plus 5i. This subtraction sign goes to everything. So 3 plus 7i minus 6 minus 5i. So 3 minus 6 is negative 3, and 7i minus 5i is negative 2i. Letter B, we have 7 plus the square root of negative 18 minus 3 plus 5 times the square root of 2i. Well, the square root of negative 18, we can't leave it like that. So 7 plus the square root of 18 can be written as 9 times 2. So square root of 9 is 3, and we're left with 2 on the inside. And because it's a negative square root, we have I that comes on the outside. Distribute a negative to each of these. So we have negative 3 minus 5 times the square root of 2i. Now, just like any normal radicals, we can only combine radicals with i's with them if they are the exact same base, meaning square root of 2, square root of 2. If it was square root of 18 or square root of 5 or anything like that, we couldn't combine them. So this leaves us with 7 minus 3 is 4, and positive 3 square root of 2i minus 5 square root of 2i is minus 2 times the square root of 2i. Now, example C, we are subtracting two fractions. So the first thing we want to do is get a common denominator between them, which means multiplying the first one by 1 minus I over 1 minus I, and the second one by 1 plus I over 1 plus I. So in the numerator, we'll distribute. That's going to give us 2, and maybe we should write out 2 minus 1 minus I minus 3 times 1 plus I over I, or 1 minus I times 1 plus I. Okay, then we can distribute 2 minus 2i. And we distribute the negative 3, so minus 3 minus 3i over, well, the denominator, because we have the same thing but one is plus and one is minus, we can do that shortcut where we just multiply the first two and the last two, because if we FOIL, it's going to cancel out. So we have 1 minus I squared. So I squared is equal to negative 1. We had talked about that previously. We talked about that last year. So we have 2 minus 3 is negative 1. 2 minus 3. And then negative 2i minus 3i is minus 5i over 1 minus negative 1. Because I squared is negative 1. So that will give us 1 minus 5i over 1 minus negative 1 is 2. Now, oops, forgot the negative. Now we have to separate it between real and imaginary parts. Right now they're under the same fraction. So as silly as it may seem, standard form of a complex number has a clear separation between the real and imaginary part. So we're actually undoing the common denominator, or undoing the single fraction. So this would be our final answer. So down here we're going to multiply complex numbers. So you can do this one of two ways. You can multiply first and then deal with the radicals, or multiply that, or deal with the radicals and then multiply them later. Because these are perfect squares, and because I'm trying to not use a calculator, I'm going to simplify the radicals first. Well, the square root of negative 9 is 3i, times the square root of negative 36 is 6i. So 3i times 6i is 18i squared. Well, I squared again is negative 1. So we have 18 times negative 1, which is going to be 18. So letter B, we have the square root of negative 50 squared. Well, we know that the square root and the square cancel, so this is just going to be negative 50. We're left with the stuff inside the radical, negative 50. Letter C, we're multiplying, so we're going to have to FOIL. 5 times 4 is 20. 5 times negative 7i is negative 35i. 3i times 4 is 12i. And then 3 times negative 7i is negative 21i squared. We know I squared is negative 1, so 20 minus 23i by combining these terms, minus 21 times negative 1. So 20 minus 23i plus 21. So then we combine our like terms of 20 plus 21, that's 41 minus 23i. So 3 minus 5i squared is 3 minus 5i times 3 minus 5i. And we could do the shortcut as well, where we multiply the first term squared, so 9, minus 3, let me use that for 3 times 5i times 2, which is negative 30i, and then times the last term squared, so negative 5i times negative 5i is positive 25i squared. Now, you could multiply this out if that didn't make sense to you, and you simplify it, you will get the same thing. Now, we're going to cut to the chase with our positive 25i squared. I squared is negative 1, so negative 1 times 25 is negative 25. And now we can combine 9 and negative 25 to get negative 16 minus 30i. Letter E. You may notice, oh, we have minus negative square root of 9 plus square root of 9. Can we do our little shortcut where we multiply just the first things and the last things? We can't, because the first things are different. So we are going to have to FOIL this eventually. But first, I would write this as 4 minus 3i times 2 plus 3i. Change the square root of negative 9 to 3i. Then when we FOIL, we get 8 plus 12i minus 6i minus 9i squared. So 8 plus 6i minus 9i squared. Again, I squared is negative 1, so that becomes plus 9. And then my simplified answer is going to be 17 plus 6i. And the last one here, we do have our special pattern because we have 4 plus 7i, 4 minus 7i, so we can multiply the first terms and multiply the last terms, so negative 49i squared. So it's going to be 16 plus 49, because I squared is negative 1, times negative 49 gives you positive 49. So this is 65. Now, this shortcut works because we have conjugates. And we had conjugates when we did rationals in the denominator. We have conjugates when we have complex numbers. So the conjugate of a plus bi is a minus bi. And we've done this a couple times already where if we have a plus bi times a minus bi, we can just multiply the first terms and the second terms, and the middle term will cancel out. If we do a plus bi times a minus bi, and you FOILed that, you get a squared, and then minus abi plus abi, because when we multiply, the order doesn't matter, minus b squared I squared, which is -1. So it actually becomes plus b. A squared plus b squared. Okay. But if that doesn't make sense, you can always just substitute I squared to be -1. It's just something that we can do as a shortcut. And like I said, these cancel out. So on the next page, we're going to be dividing complex numbers. And again, when we divide complex numbers, we're going to multiply the top and bottom by the conjugate of the bottom. So in the numerator, we are going to have to FOIL the numerator. But in the denominator, we can use what we did back here, a squared plus b squared. Or we can do the -1 substitution. It doesn't matter. So we have in the numerator 12 plus 9i plus 8i plus 6i squared over 16. And yes, we could write minus, 4 times 4 is 16, minus 9i squared. But like I said, we know that I squared is -1, so it's actually 16 plus 9. So we have 12 plus 17i in the numerator plus 6 times -1, so this is going to be -6 over 16 plus 9. Make this a little bit neater. So 12 minus 6 is 6. 6 plus 17i over 25. And then we need to write this as two separate fractions. 6 over 25 plus 17 over 25i, or you can write it as 17i over 25. That would be your simplified answer. All right, letter B is a little bit different because the denominator isn't a complex number that has a real part and an imaginary part. It just has an imaginary part. So we just have to multiply the top and bottom by, you could do 2i or you can do I, because remember the idea is we don't want the imaginary number in the denominator. So I'm going to multiply the top and bottom by I, because that will get rid of the I in the denominator. If you do 2i, it'll still do the same thing. You'll just have to simplify later down the road. So if I do this, this is going to be 8i plus 20i squared over 2i squared, as we distribute here. Okay, so that's going to be 20i squared is going to be -20 plus 8i over 2i squared is going to be -2. So then we got to simplify this fraction. We can divide everything here by -2. So I'm going to get 10 plus, sorry, not plus, because I'm dividing everything by -2, 10 minus 4i over 1. And we don't want to write over 1, so it just becomes 10 minus 4i. All right. Now, we've only been dealing with I and I squared, but in reality, we could keep raising I to different powers, and we're going to see a pattern. So we know I is the square root of -1. We know I squared is -1. Well, I to the third is I times I squared. All right, so now I to the third is I squared times I. Well, I squared is negative 1, so negative 1 times I is this going to give us negative I. I to the fourth. Well, I to the fourth can be written as I squared times I squared. Well, I squared is negative 1, so negative 1 times negative 1 is positive 1. So I to the fourth is positive 1. Well, I to the fifth now. I to the fifth can be written as I to the fourth times I. We just said that I to the fourth power is positive 1, so this is going to be positive 1 times I, which is just going to be I. Okay, I to the sixth. I to the sixth can be written as I to the fourth times I squared, because we can add those exponents. Well, again, I to the fourth is positive 1. I squared is negative 1. Positive 1 times negative 1 is negative 1. Are you starting to see a pattern here? We have I, which is the square root of negative 1. I to the fifth was also I. I squared was negative 1. I to the sixth is negative 1. Okay, well, if you don't see it, we'll go one further. I to the seventh is I to the fourth times I to the third. Again, I to the fourth is 1. I to the third is negative I. So this is going to be negative I. And then I to the eighth is I to the fourth times I to the fourth. 1 times 1, which is 1. So our pattern is repeating, and we can make this pattern go on forever. It repeats every 4 times. So our pattern goes I, negative 1, negative I, positive 1. So in these problems down here, what we're going to do to find our powers of I is we're going to divide by 4 and see what our remainder is, and that will tell us which one of these to use. Now, if we get a whole number when we divide by 4, then we know it's going to be 1, and then a remainder of 1 will be I, remainder of 2 will be I squared, remainder of 3 will be I to the third. So 107 divided by 4. Okay, it goes in 2 times 8. 4 goes into 27 6 times. 6 times 4 is 24. We're left with the remainder of 3. Well, that means that this is going to be equal to I to the third power. So let's write that down here. I to the third power, which is negative I. Then we have 52. I to the 52 divided by 4. Okay, 51. We get 4. 13 with no remainder. So this is equal to I to the fourth, which is positive 1. Okay, then we have 71. Okay, so then 71 divided by 4, go in once. Okay, it goes into 31. 8 times 4 is 28, and we get a remainder of 3. So it's going to be the same as letter A, I to the third power, which is negative I. All right, letter D, we have the square root of negative 3 raised to the sixth power. So we can write this as the square root of 3I to the sixth power, and we can write the square root of 3 as 3 to the 1/2. So we have 3 to the 1/2 power times I to the sixth. We can then distribute the sixth power, and we get 3 to the 1/2 times 6 is 3 times I to the sixth. 3 to the third is 27. I to the sixth can be written as I to the fourth times I squared. I to the fourth is 1. I squared is negative 1, so our answer is negative 27. All right, last example here. We're going to solve quadratic equations. And now that we have reintroduced I into our vocabulary, the imaginary number, we can solve if we have negative square roots. So let's get at it. We get x squared equals negative 8. When we square root both sides, we get x equals plus or minus. The square root of 8 will simplify to 2 times the square root of 2. But because it's negative, negative 8 is going to have an I at the end. Right, letter B. First, I'm going to see if I can factor that. Can we factor that? Are there two numbers that multiply to 15 but add to negative 2? Nope, there are no two numbers, so we're going to have to either complete the square or quadratic formula. I would quadratic formula because our a value is not 1, and we have everything equal to 0 already. So x equals negative 2, so 2 plus or minus the square root of negative 2 squared minus 4 times a times c, all over 2 times 3. So we get 2 plus or minus the square root of, that's that discriminant right here. This is going to multiply out on our calculators to negative 56 over 6. All right, so then we have x equals 2 plus or minus. The square root of 56 can be broken up into 4 times 14. Well, 4 times 14, the square root of 4 is 2. Square root of 14, and then we have I all over 6. And since we can reduce all of these by 2, this is going to be 1 plus or minus the square root of 14i over 3. And then finally, we have to write this separated out as 1/3 plus or minus the square root of 14i over 3. So this is stuff that we've talked about before. Again, we're just taking it to the next level and kind of reminding us of what we're supposed to do in these situations. So thanks for watching. Make sure to like this video and subscribe.